Ship stabilizers are fins or rotors mounted beneath the waterline and emerging laterally from the hull to reduce a ship's roll due to wind or waves. Active fins are controlled by a gyroscopic control system. When the gyroscope senses the ship roll, it changes the fin's angle of attack to exert force to counteract the roll. Fixed fins and bilge keels do not move. They reduce roll by hydrodynamic drag exerted when the ship rolls. Stabilizers are mostly used on ocean-going ships. Function: fins work by producing lift or downforce when the vessel is in motion. The lift produced by the fins should work against the roll moment of the vessel. To accomplish this, two wings, one installed underwater on either side of the ship, are used. Stabilizers can be retractable. All medium and large cruise and ferry ships have the ability to retract the fins into a space inside the hull in order to avoid extra fuel consumption when the use of the fins is not needed. Non-retractable: this is the case on very small ships, for example a yacht. Stabilizer movement is similar to that of aircraft ailerons. Some types of fins, especially the ones installed on larger ships, are provided with flaps that increase the fin lift by about 15%. Stabilizer control needs to consider numerous variables that change quickly: wind, waves, ship motion, draft, etc. Fin stabilizers are vastly more efficient at higher velocities and lose effectiveness when the ship is under a minimum speed. Stabilization solutions at anchor or at low speed include actively controlled fins, and rotary cylinders employing the Magnus effect. The latter two systems are retractable, allowing for a thinner vessel profile when docking, and reducing drag while cruising. Fuel consumption and carbon emission. Fin stabilizers are used to reduce the roll motion of the ship and improve the passenger's comfort. However, they can be a considerable hydrodynamic brake for the ship. Stabilizers can reduce a ship's speed due to an increase in hydrodynamic drag. This increases fuel consumption and CO2 emissions. Some ships employ systems to reduce the stabilizer's energy dissipation by using computers to control their motion. This reduces their fuel consumption and CO2 emissions. History: the bilge keel is an early 20th century stabilizing innovation, not as effective at reducing roll, but easier to install, and does not require space inside the hull. An earlier stabilization technology was gyroscopic stabilization. The World War I transport Henderson, completed in 1917, was the first large ship with gyro stabilizers. It had two 25-ton, 9-foot diameter flywheels mounted near the center of the ship, spun at 1100 rpm by 75 HP AC motors. The gyroscope cases were mounted on vertical bearings. When a small sensor gyroscope on the bridge sensed a roll, a servo motor would rotate the gyros about a vertical axis in a direction so their precession would counteract the roll. In tests, this system was able to reduce roll to 3 degrees in the roughest seas. The ship Conte I Savoir, which first sailed in November 1932, had 3 flywheels which were 13 feet in diameter and weighed 108 tons. Gyroscope stabilization was replaced by fin stabilization due to its lower weight and bulk. The first mention of automatic stabilizers for ships was in 1932 by an engineer working for General Electric. The first use of fin stabilizers on a ship was by a Japanese cruise liner in 1933. In 1934, a Dutch liner introduced one of the world's most unusual ship stabilizer systems, in which 2 large tubes were mounted on each side of the ship's hull with the bottom of the tubes open to the sea. The top of the tubes had compressed air or steam pumped in. As the ship rolled, the side it was rolling to would fill with water and then compressed air or steam would be injected to push the water down, countering the roll. In 2011, the first fuel-saving stabilizer control to have been proven to improve ship speed, and to reduce fuel consumption and CO2 emissions when using stabilizers was installed on board a passenger ship.